Project Management Professional Training Session 14 Part C. Forecasting Techniques. Forecasting refers to predicting some information about the project in the future based on the performance in the past. The forecast is regularly updated as the project progresses and more data of the past performance becomes available. Estimate to complete, etc., at budgeted rate. This is a prediction about the expected cost to complete the remaining work for the project or for a project activity. The future work is assumed to be completed at the budgeted rate. Therefore, the value of the ETC is obtained by subtracting the earned value, EV, from the budget at completion, BAC, as shown in the formula here, ETC equals BAC, EV. So, in our example, the value of ETC can be calculated as ETC equals $600,000 to $150,000 equals $450,000. This is true if the current variances are seen as atypical and the future performance is expected to be as planned. If the current trend, however, continues, then we need to take CPI into account, as shown next. Estimate to complete, ETC, at the present CPI. This is the prediction about the expected cost to complete the remaining work at the present CPI. Therefore, in that case, the ETC is given by ETC back EV CPI equals. The next question that can be asked about the future is how much it will cost to complete the whole project. Study checkpoint 13.5. In our running example, calculate the ETC at the present CPI. Estimate at completion, EAC. At the budgeted rate, this is the estimate made at the current point in time for how much it will cost to complete the whole project or a project activity from beginning to end. It is assumed that the future work will be performed at the budgeted rate. Therefore, the value of the EAC is obtained by adding the value of ETC at the budgeted rate to AC, as shown in the formula here, EAC equals AC plus ETC, budgeted rate. Accordingly, the value of EAC for our example can be calculated as EAC equals $125,000 plus $450,000 equals $575,000. Another useful prediction to be made is how much performance you need in the future to complete the remaining work within budget. Study checkpoint 13.6. Prove the validity of the following equation. EAC equals AC plus BAC, EV. The EAC calculated thus far is correct under the assumption that in the future the cost will be incurred as it was budgeted, or performance will be made as planned. If, however, the current variance trend is assumed to continue, then EAC is calculated as discussed next. Estimate at completion, EAC, at the present CPI. This is the estimate made at the current point in time for how much it will cost to complete the whole project or a project activity from beginning to end. It is assumed that the future work will be performed at the current CPI. Therefore, EAC is calculated as follows: EAC equals AC plus ETC. At current CPI, EAC AC back EV CPI equals plus. Study checkpoint 13.7. In our running example, calculate EAC at the present CPI. As said earlier, performance is an integrated measure of progress in the areas of scope, schedule, and cost. Just measuring one of these parameters may be misleading. For example, in our running example, we are performing better in cost but poorly in schedule. This is why sometimes EAC is measured by taking into account both CPI and SPI, as shown here. EAC AC back EV. CPI SPI. Study checkpoint 13.8. In our running example, calculate EAC at the present CPI. To complete performance index, TCPI. This is the variable to predict the future performance needed to finish the work according to a specified goal, for example, either within the planned budget, BAC, or at the completion cost currently predicted, EAC. If the goal is to complete it within BAC, TCPI is calculated as the ratio of the remaining work to the remaining budget, as shown in the formula here. TCPI remaining work. Remaining funds. BAC BCWP. BAC ACWP, BAC EV, BA equals CAC. Therefore, the value of TCPI in our example can be calculated as TCPI equals $600,000 to $150,000 /600,000 to $125,000 equals 450,000 475,000 is equal to 0.95 equals 95%. If it is realized that BAC is not attainable, then it is replaced with EAC accordingly. TCPI will be given by TCPI remaining work remaining funds. BAC of EAC AC equals. Table 13.7 summarizes most of these performance variables. Caution: depending on what information is known, these variables can be expressed in different equations, as shown by study checkpoint 13.6. But sticking to the definitions of these variables, it can be realized that all these different forms of equations for a variable are all equivalent. The analysis presented here is a good demonstration of how schedule and cost are coupled together, and both obviously depend upon scope. The success of a project depends on completing the project according to the schedule with full planned scope and within the planned cost. These three parameters, scope, schedule, and cost, are intrinsically related to one another. Scope, schedule, and cost, the triple constraint. The nutshell of running a project is delivering the scope according to some schedule, and it's going to cost someone. Completing a project successfully includes delivering the planned scope according to the planned schedule and within the planned budget. The fundamental parameters for budget and schedule are cost and time, respectively. Budget is the cost with a timeline, and schedule is determined from the time estimates for completing the schedule activities defining the scope. So scope, schedule, and cost make the heart of any project. These three project parameters also make up a triple constraint that is a framework for evaluating competing demands. A triple constraint can be depicted as a triangle, with each side representing one of these three parameters. Figure 13.4 shows the triple constraint for scope, schedule, and cost. This means if one of these parameters changes, at least one of the other two must change as well. Caution: the present version of PMBOK does not formally discuss the triple constraint of scope, cost, and schedule. However, the formal name aside, it remains a fact that scope, schedule, and cost are tightly coupled as reflected by the integrated performance measurement baseline and the earned value analysis. Therefore, the discussion in this section is still valuable. In Figure 13.4, you cannot change the length of one side of the triangle without changing the length of at least one of the other two sides. For example, assume you are being interviewed by a functional manager for a project manager position. Don't be surprised if you are asked a question based on the following situation. 1. The project is way behind schedule. 2. No extra resources, such as money or project team members to perform activities, are available. 3. You have to implement all the planned features. The question is, what will you do to meet the deadline that is approaching within a week? From a project management viewpoint, this situation is a good example of the triple constraint. The project is behind schedule, which means there is a schedule change, or a change in time available to finish the remaining project. Recall about project scheduling from Chapter 6 that your options in this situation are pretty limited, such as applying leads and lags, floats, and smoothing techniques. In most of these situations, at least one of the other two parameters must change. If you want to meet the deadline, either you should be allotted more funds to hire more resources, or the scope of the project should be changed, which means some of the features would be left out. Depending upon the knowledge level of the functional manager about project management, this answer might not get you the job, but as a project manager, you must stand your ground. Project management is not magic, it involves dealing with cold, hard reality in a realistic way, thereby establishing clear and achievable objectives. Note: while considering the cost schedule scope constraint, you should also remember techniques like resource leveling and smoothing, applying leads and lags, and schedule compression techniques, such as crashing and fast tracking, discussed in Chapter 5. Also remember that those techniques do not guarantee that no additional cost, or resources, will be required. You can see the relationship of the triple constraint with quality by recalling that a high-quality project delivers the required product on time and within the planned scope and budget. Therefore, while balancing between these three constraints, the quality, and as a result, customer satisfaction, might be affected. The triple constraint is also a good example of how one change can give rise to other changes across the project. This highlights the importance of managing and controlling changes. Changes to scope, schedule, and cost are controlled using the control scope, control schedule, and control cost processes, respectively. These three processes are at the center of the project action. As Figure 13.5 illustrates, they take work performance data from the project execution process, the direct and manage project work process, and the generate work performance information process that are used by the monitor and control project work process to generate the work performance reports. Study Checkpoint 13.9. Name 3 processes that convert the work performance data into work performance information. The 3 most important takeaways from this chapter are as follows. 1. To avoid scope creep and to ensure that the scope is implemented, you need to control the scope. Also, the scope of the project outcome needs to be validated before the acceptance of the verified product. 2. The schedule needs to be controlled to keep the project on track, i.e., in alignment with the schedule baseline. The major output items of the schedule control process are work performance information, schedule forecasts, and change requests resulting from comparing the schedule-related work performance data with the schedule baseline. 3. Cost control involves converting the cost-related work performance data into work performance information by comparing the data with the integrated baseline, scope baseline, schedule baseline, cost baseline. Summary. The nutshell of running a project is delivering the scope according to some schedule, and it's going to cost someone. These 3 parameters, scope, schedule, and cost, are intrinsically related to one another. A change in one is likely to cause changes in one or both of the others. Changes in any of them may cause changes in resources. The scope is controlled by the control scope process, and the scope of verified deliverables is validated by using the validate scope process. You need to control the schedule to keep it aligned with the schedule baseline, which includes monitoring the status of the project progress and controlling changes to the schedule baseline. Reflecting this triangular relationship, the project cost performance is measured by comparing the project execution results against the performance measurement baseline, which is an approved integrated plan for scope, schedule, and cost for the project. In other words, the performance baseline includes scope baseline, cost baseline, and schedule baseline. This is done in the control cost process. Finally, use the control resources process to optimize the results by keeping the planned, allotted, and used physical resources in sync with each other. Road ahead. To run controlling or any processes successfully, it's crucial to keep stakeholders engaged in the project, which takes effective communication. Stakeholder engagement and communication need to be monitored. The next chapter is all about that. Exams I view. Comprehend. Monitoring and controlling includes monitoring and controlling project performance and managing the resulting changes. The 3 project parameters, cost, schedule, and scope, form a triple constraint, which means if one of these 3 parameters changes, at least one of the other 2 must change. Performance measurement baselines and work performance data are the common input to controlling the scope, schedule, and cost, and work performance information and change requests are the common output. Project cost performance is measured by comparing the project results from work performance data against the performance measurement baseline, scope baseline, schedule baseline, and cost baseline. Look out! All change requests generated by controlling scope or any other process must be processed through the integrated change control process for approval, and only approved changes should be implemented by using the direct and manage project work process. The validate scope process is used on the project deliverables already verified by the quality control process. The goal is to get deliverables accepted by the appropriate party, such as a customer or a sponsor. The approved version of the project schedule is called the project schedule baseline, against which project progress is tracked and measured by comparing the actual progress with the baseline. The control resources process is all about keeping the planned, allotted, and used physical resources in sync with each other. The control resources process is about physical resources only. Planned value, PV, earned value, EV, and actual cost, AC, are the three key parameters that need to be monitored closely. The rest of the earned value analysis is based on these three fundamental parameters. Cost variance, CV, is calculated by subtracting the actual cost, AC, from the earned value, EV, and not from the planned value, PV. Schedule variance, SV, and schedule performance index, SPI, are calculated in terms of cost, EV and PV. It is possible for CV and SV to run in opposite directions. For example, CV has a positive value when SV has a negative value. The total planned value, PV, of the project is the same as the budget at completion, BAC. Memorize. Control accounts are the points in the WBS at which scope, schedule, and cost are integrated for the purpose of monitoring and controlling the performance. The control schedule process, by comparing the schedule-related work performance data with the schedule baseline, produces the work performance information containing the schedule variance, i.e., deviation from schedule baseline, and schedule forecasts are based on this and past performance. In every stage or funding period, cost baseline equals anticipated expenditure plus anticipated liabilities. Funding requirements equals cost baseline plus management reserves. For cost performance analysis, EV equals BAC times work completed / total work required. CV equals EV/AC. CPI equals EV/AC. For schedule performance analysis, PV equals BAC times time passed / total schedule time. SV equals EV/PV. SPI equals EV/PV. EAC at the budgeted rate equals AC plus BAC EV. EACAT current CPI AC back EV. CPI equals plus EACAT current CPI and current SPI AC back EV. CPI SPI equals plus TCPI BAC EV. BAC AC. Review questions. 1. Which of the following is the correct order of running processes? Choose all that apply. A. Develop project charter, collect requirements, and create WBSB, collect requirements, control quality, and validate scope. C. Identify stakeholders, define scope, and collect requirements. D. Collect requirements, validate scope, control quality. 2. You have selected a node in the hierarchy of the WBS that you will use to compare schedule, cost, and scope with the earned value in order to measure the project performance. This node or component in the WBS is called A. Code of accounts. B. Control account. C. Management account. D. Performance node. 3. You are the project manager for a software product, and your project is in the execution stage. You have learned that Maya, a developer, has started adding some new features to the deliverable she is working on. What is the best action for you to take? A. Tell Maya to delete the code corresponding to these features because this is scope creep, and scope creep is not allowed. B. Learn from Maya what those features are and how much time they will take and then make necessary updates to the WBS dictionary, and the schedule. Also tell Maya that in the future she should get approval from you before adding any new features. C. Determine where the request for the new features came from and process the change request through the integrated change request process. 4. Which of the following is a true statement about the critical path? A. Each activity on the critical path has zero float time. B. It controls the project finish date. C. It controls the project start date. D. It is the shortest sequence in the network diagram. 5. You have developed the schedule for your project, and you've called the kickoff meeting. A team member who is responsible for an activity comes to you and tells you that the activity cannot be performed within the allocated time because some pieces were left out during activity definition. The revised estimate will add 2 more days to the activity duration, but the activity is not on the critical path. Which of the following actions will you take? A. Go to the team member's functional manager and find out whether the team member's estimate is correct. B. Accept the new estimate but do not change the schedule. C. Accept the new estimate and update the schedule accordingly. D. Put the new estimate through the integrated change control process. 6. Your project sponsor has asked you to ensure that allotted resources are used, and used resources are immediately released, and no unplanned resources should be allotted. To ensure that, which process would you run? A. Plan resource management. B. Control resources. C. Manage resources. D. Acquire resources. 7. Assume that you are the project manager for the construction of a 15-mile road. Further assume that the work is uniformly distributed over 12 weeks. The total approved budget for this project is $600,000. At the end of first 3 weeks of work, $160,000 has been spent, and 5 miles of road have been completed. What is the earned value of the project at the end of the first 3 weeks? A. $160,000. B. $200,000. C. $150,000. D. $600,000. 8. Assume that you are the project manager for the construction of a 15-mile road. Further assume that the work is uniformly distributed over 12 weeks. The total approved budget for this project is $600,000. At the end of first 3 weeks of work, $160,000 has been spent, and 5 miles of road have been completed. What is the planned value of the project at this point in time? A. $160,000. B. $200,000. C. $150,000. D. $600,000. 9. Assume that you are the project manager for the construction of a 15-mile road. Further assume that the work is uniformly distributed over 12 weeks. The total approved budget for this project is $600,000. At the end of first 3 weeks of work, $160,000 has been spent, and 5 miles of road have been completed. What is the cost variance? A. $40,000. B. $50,000. C. Minus $40,000. D. $120,000. 10. Assume that you are the project manager for the construction of a 15-mile road. Further assume that the work is uniformly distributed over 12 weeks. The total approved budget for this project is $600,000. At the end of first 3 weeks of work, $160,000 has been spent, and 5 miles of road have been completed. What is the schedule variance? A. $40,000. B. $50,000. C. 3 weeks. D. 12 weeks. 11. There is a CPI value of 1.25 and an SPI value of 1.33 for a project. This means which of the following? A. The project is making slower progress and costing more than planned. B. The project is making faster progress and costing less than planned. C. The project is making slower progress and costing less than planned. D. The project is making faster progress and costing more than planned. 12. Project cost performance is measured by comparing the project results from work performance data against the integrated performance measurement baseline. Which of the following are the 3 elements of this integrated performance measurement baseline? A. Scope baseline, time baseline, and cost baseline. B. Scope baseline, schedule baseline, and quality baseline. C. Scope baseline, time baseline, and quality baseline. D. Schedule baseline, scope baseline, and cost baseline. 13. You are managing a project in biotechnology code named Mitochondria Eve. You need work performance measurements or information to write the performance reports. Which processes will you run? A. Monitor and control project work. B. Control scope, control schedule, and control cost. C. Develop project work performance report. D. Direct and manage project work.